Hi guys, welcome back. Today, grade 10 learners. We are answering electrostatics questions for you guys. Okay, first of all, as a reminder, please try first. Practice makes perfect. So please try first, write your answers down, and then check your answer is correct or something is wrong, something is missing. Okay, let's start and answer our question 1. Okay, question 1, it is your turn. Please stop video and try first. All right, so I hope you have done already. Now we are gonna carry on. I'm just saying you stop and try. Please write your answers down. All right, so what type of force do they exert on each other? So this is our question. We have two charges, object A and B. Object A with -6 coulombs, you know C is coulombs, and then object B has -2 coulombs. So you just check they have same charges, negative, positive, or negative. If they have same charges, we have repulsive force. We should say repulsive electrostatic force. Electrostatic force. This is our answer, just writing repulsive electrostatic force, because we have same charges, negative and negative. If you have like charges, not say, let's say like and unlike, like charges repel each other. So like charges, we should remember this point, like charges repel. So we have repulsive electrostatic force. If they said with same charge, with unlike charges, if we have unlike charges, what's going to happen? They're going to attract each other. So that time we are going to say attractive force. Unlike charges, they attract each other. So remember, like charges repel, unlike charges attract. Okay, question 1 done. Let's continue with next question, question 2. Same charge object, they touch each other and separate from each other. So what type of force do they exert on each other? All right, same object, so object A and B, they touch each other and separate. Okay, please try. It's your turn. Please stop video and try first. Okay, after that, we can start, we can answer together. Now, what we know, when they touch each other, they're gonna get same charge. They don't ask you calculate it, but if you calculate, we are gonna use this way. Q final is equal to Q1 plus Q2 over 2, first charge plus second charge over 2 equals, we have -6 plus -2 over 2, getting -4 coulombs. Okay, let's write what is C coulomb. All right. So unit of charge. As you see, they are going to have same charge, both of them getting -4 coulombs after touching each other. So now also they have negative and negative charge, same charge. And we are writing one more time, repulsive electrostatic force. Electrostatic force. All right, this is our answer for this question. What type of force? We have repulsive electrostatic force. Done. If you just say electrostatic force, also fine, but let's explain, let's say all details. Okay, next question, same objects with question 3. Question 3, they touch each other. Now, when they touch each other, what is the direction of electrons transfer? Yes, which direction? Electrons moving which way? Okay, your turn. Please try. It's time to try. And then we are going to answer. A few seconds I will wait for you. Just pause the video and try. All right. Okay, let's continue. Guys, for this kind of questions, we should remember electrons move from less charge to more charge, from less number also we can say. You can use number line for this, maybe just 0, -1, -2, -3, because sometimes we have negative positive charges, +1, +2, +3. So this way, electrons transfer always this way to the right. So from less number, from less charge to big one, large one. So what numbers we have? -6 coulombs and -2 coulombs. As you know, -6 is less number than -2. So electrons moving A to B. What we have to remember for this kind of questions, from less number to big number, done. Question 3, like this, I hope your answer is right. So question 4 is coming now. Question 4, they ask you calculate new charge. Oh, we calculate already. Okay, no need to try this one because we done already in question 1. So what is new charge for this one? Let's calculate together one more time. Q final equals Q1 plus Q2 over 2. Q1 is -6 plus -2 over 2. Q final is equal to -6, -2, -8 over 2, getting -4 unit coulombs. We have to write unit, otherwise we are losing our marks. So question 4, just like this. We have done question 4 also. I hope everything is fine. Let's see what they ask for next question. Question 5. Calculate the new charge on the object B. Okay, just to understand that process, calculating new charge on object A, new charge on object B, same calculation. You just calculate Q final and same calculation. Q final is equal to Q1 plus Q2 over 2. You are going to get -4 coulombs. We don't need to recalculate. The same stuff. All right, you just add. I just made different question because just to understand, they are getting same charge. End of day, getting same charge. Question 5, another easy one. Next one, bit longer. This question 6. It's time to try this question. We have 2 steps for this question. 2 different formulas we are going to use. Calculate how many electrons are transferred. Okay, it is your turn. Please try. Question 6. You are going to calculate how many electrons when they touch each other. A and B, they touch each other and then getting how many electrons? How many electrons transferred? We know A to B. All right, your turn. Please try. Just waiting for you, just to stop video and then try first. Please use this method because trying is the key, guys. If you try, you're going to be happy. If you try, you will get it. Try or die, I was saying to my learners. So try and get your good results. Okay, how many electrons are transferred? For this kind of questions, what we are going to do? First of all, we should get final charge. We done already final charge in other questions 2 times. We calculate final charge Q1 plus Q2 over 2, -6 plus -2 over 2, getting -4 coulombs. And then we are going to use charge equals N times QE. Number of electrons times charge of electron. From this formula, we can write N equals charge over QE. But which charge we are going to use? Change in charge, delta Q. We are calling delta Q. Q final minus Q initial over QE. So number of electrons equals. So Q final we calculate and then we have -4 minus. For Q initial, you can use charge for A, Q1 or charge for B, Q2. Let's use for B and -2 divided by QE. 1.6 times 10 to the power of minus 19. This is constant number in formula box. You can find it. So -4 and +2. Remember, negative, negative, getting positive. And then 1.6 times 10 to the power of minus 19. On top, we have -2. Yeah, this point is very important. If you have on top -2, you must just use -1.6, -1.6, and then negative, negative, negative divided by negative, getting positive. 1.6 times 10 to the power of what we have, minus 19. We should just calculate this one and getting answer. All right, now we are getting our answer. Our answer is number of electrons equals, let's write it here, what we have, 1,25 times 10 to the power of 19 electrons. Done. So this is our solution for how many electrons transfer. So far, other questions easy, but only this one with 2 steps, with long. But when you go to other questions, similar questions, you are gonna get it. So next question is coming, question 7. For question 7, what type of force between these two, A and B? Now we have 0 coulombs and plus 2 coulombs. All right, please try first. And we can answer together. This one is another simple one. Because of polarization, they attract each other. So attractive electrostatic force. Attractive electrostatic force. This question, sometimes they ask you name of force, sometimes type of force, sometimes you know which force. So just let's write everything just in case. So, and then because of polarization, guys, this is because of polarization, they attract each other, because if you have neutral object, it means all protons, electrons everywhere, right? So just like this. But when this positive charge is coming closer, electrons coming on this side surface and only protons left behind. So this is polarization process. All right, if you have neutral object for polarization, that's right, polarization. Polarization process, if you have neutral object, plus, minus, plus, minus, plus, minus. If one object is coming closer with charge, let's say positive charge, if positive charge is coming closer, all electrons coming this side, and then protons just left behind. So protons, 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 electrons coming this side. And then finally you have, finally they attract each other. Okay, if they ask you reason why they attract each other, neutral charge object and neutral object, then why they attract each other, because of polarization. All right, let's continue with next question. What type of force? One more time, they're asking you, but now it was attractive electrostatic force, but now let's see, attractive or repulsive. Please try first. They touch and separate from each other. They touch and separate from each other. This is our question 8. Just a few seconds for you. Please try first. There's no calculation, just try to know what kind of force after contact each other. After contact each other, boys, girls, we have same charge and getting repulsive electrostatic force. That's right. Repulsive electrostatic force. Why? Because when they touch each other, 0 plus 2 over 2, get 2 and getting 1 coulomb. Both getting 1 coulomb, 1 coulomb. They're going to ask following question. Because of that, we don't need to write full solution. But our answer is repulsive electrostatic force. Next one. What's the direction of electrons transfer? Yes, please try. A to B or B to A. We'll take 1 second. 1 second to answer this question. The simple one. Yes, you know already, but please try first. But try first, it means write it down, your answer, and then mark your answer. Maybe you can say true, correct, or false, and then you can check which point you don't get it. On the comment, maybe you can share with me If you have any question, any difficulties, if all sharp, everything is good, also you can share with me. Just we can communicate and then we can help each other. So let's continue. 0 coulombs and 2 coulombs. What direction electron transfer? Of course, A to B, because 0 is less than plus 2. That's it. What we said, from less number to big number, from less charge to big charge, large charge. Question, question number is coming now. Okay, question 10. Now calculate the new charge on the object A, or question 11, same question on the object B. Let's answer both of them. Object A, object B. Just one calculation, please calculate. Calculate the new charge on the object. You stop the video, you did try, and you are with me now. So let's answer together. So calculate the new charge on the object B, or object A, or new charge on each object. You know, they can ask that kind of question, same calculation, because they are having same charge end of day. Q final equals Q1 plus Q2 over 2. Our numbers, what we have, 0 plus 2 over 2, and then 2 over 2 is 1 coulomb. We should write unit. C is coulomb, unit of charge, you know that. Question 10, 11, done. So same questions. Let's continue with next one. How many electrons are transferred? Yes, this question is taking time. We are looking for how many electrons transfer, but we know already the final answer. We calculate, we don't need to make 2 steps. Just use that one here. Q final, when they touch each other, Q final, 1 coulomb for each. Okay, use this one, and then please try to get answer. How many electrons transfer? Using QE charge. Yes, you stop video, you did try, and please attention to get correct answer. Okay, now we are using, first of all, of course, calculating final charge, if they don't ask me another question. After that, Q equals N times QE. And then from this formula, we can write N equals charge over QE. But now we are going to use delta Q. So N equals Q final. N is number of electrons transferred. Q final minus Q initial over 2. Q final is, but we have 1. We said we calculated 1 minus, let's use 0 to make it easy. But we did mistake here, not 2, QE. Q final over QE. So QE now 1 minus 0 is positive. So we can use 1.6 times 10 to the power of negative 19. 1 over 1.6 times 10 to the power of negative 19. And then you are getting 6,25 times 10 to the power of 18. What's our unit? Electrons. Done. This question also done. I hope everything is fine. From now, we are going to carry on with other questions, but same stuff. I hope it's going to be practice for you. For now, yes, question 13. Another question, another easy question. We said practice makes perfect, because when you try, you are going to learn. So question 13, similar question with different charges. Type of forces. Okay, what type of forces we have between these two? We have repulsive electrostatic force, because we have positives. Like charges repel each other. Let's write repulsive electrostatic force. Electrostatic force. This is our answer for number 13. I hope everything is fine. You just check like charges you have or unlike charges you have. If you have like charges, they repel each other, repulsive force. Next one, same process, they touch each other and separate from each other. And then they ask you what kind of force. when they touch each other, always getting same kind of charge, positive, positive, or negative, negative. So they're getting same charge and asking you what kind of force between these two. Please try first. Yes, I hope you did try. Okay, answer is repulsive. One more time. Repulsive electrostatic force. Electrostatic force. Only we should know like charges repel each other. If you have two like charges, they have repulsive electrostatic force between them. All right, question 14 done. Question 15. What's the direction of electron transfer? Yes, another point we should remember. Which direction? A to B or B to A? All right, please try and write your answer down, and then we can carry on. Our answer is A to B, because what we said, from less number to big number. So A to B is our answer. A is +2, B is +4. Answer is A to B. Another 1 mark you have. So next question. What is the new charge on the object A, or what's the new charge on the object B? These two questions together we can calculate, we can answer. We are looking for new charge on the B, new charge on the A. What is final charge when they touch each other? All right. Please try first. And then we can answer together. Yes, it is waiting a few seconds. Yes, let's start. Let's answer. Q final is equal to Q1 plus Q2 over 2. What we have now, 2 plus 2, oops, not 2 plus 2, 2 plus 4 over 2. Okay, 2 plus 4 over 2, 6 over 2 is equal to 3 coulombs. This is our final charge when they touch each other. Done. Question 17. Done. How many electrons are transferred? Yes, one more time. Long one. Long calculation. What we know, final charge we calculate already. You can use that one. Q final equals 3 coulombs. This one will take time, maybe 1 minute, 2 minutes. But please stop video, try first, write all solution and your answer. Not just your answer voice. You must write all, sorry guys, all guys. So you must just write your final answer, solution, everything, and then check everything is fine, because you are not getting mark just for answer. You are getting mark for calculations, solutions, substitution, formula, everything. Because of that, please write all details and then check your answers when we're done. Okay, please try first. Just waiting for you to try. All right, you stop and try. You have your answers with you now. And we can start, we can answer. So this is our formula. Charge equals N times QE. And let's change color, huh? Always using same color. So number of electrons, N equals delta Q over QE. We are using delta Q, Q final, minus Q initial over QE. Q final is, but we have 3 coulombs, 3 minus Q initial, let's use 2. We said we can use A or B, any of this, over 1.6 times 10 to the power of minus 19. When you calculate 1 over 1.6 times 10 to the power of minus 19, and you are getting 6,25. 6, oops. Yeah, 6, and then because power 18, yes. Unit electrons, done. Okay, so this question, calculating simple like this. All right, we have done question 18 also. We calculate number of electrons transfer. Question 18 with new charge objects, another charge object, but same questions. What type of force? Why we are asking same questions again and again? Because practice makes perfect. So when you try, it's going to be easy for you. For each question, getting easy, and then finally you are going to be okay. What type of force between these two? Please try. Repulsive electrostatic force or attractive electrostatic force, what you have between these two? Please write your answer first. Okay, you are writing down your answers, and then we can answer together on the board, together on this slide. So answer is attractive electrostatic force. Why? Because we have unlike charges, positive and negative. Positive and negative, they attract each other. Attractive electrostatic force. This question 19 done. Question 20 and oops. Oh, sorry. Question 20. I was saying just same questions. No, question 20. When they touch each other and separate, what kind of force between these two? Please try. They touch and separate from each other. When they touch and separate from each other, what is what force between them? Is your question. Please write your answer first. All right, I hope you are done already. So we can start. We can write, when they touch each other and separate, we have repulsive, because they are having same charge. Repulsive electrostatic force. I hope you are getting it. When before touching each other, we check positive and negative, or positive, what charge you have. If they have same positive, or negative, we say repulsive force. If they have positive and negative, attractive force. But after touching each other, always they are getting same charge. Because of that, always repulsive charge. All right, we have done question 20. Question 21, let's see what they ask. What's the direction of electron transfer? Yes, another point is here. What's direction of electron transfer for question 21? Please try. A to B or B to A. Direction of electron transfer. Please write it down, your answer. Yes. Done. Okay. So now we should remember electrons moving from less number to big numbers. Now, as you see, B -4, A plus +8. So now B to A. Our answer is B to A now, because A is less number, negative number. All right, B to A. 20, question 22, object new. Calculated new charge on the object A. Question 23, also same. Calculated new charge on the object B. So we are gonna get same calculation because of that. Let's do same time. Please try first. Question 23. All right, you stopped the video and you did try and then came back. Yes, so let's start and let's answer. Q final equals Q1 plus Q2 over 2. So what we have, 8 nanocoulombs. Oh, this is nanocoulombs. So 8 times 10 to the power of -9. After this question, let's remember all these units. Okay, because nano 10 to the power of -9 plus -4 times 10 to the power of -9 over 2. So 4, and then getting 2 times 10 to the power of -9 coulombs. If you want, you can make another method by using nanocoulombs. You can say Q1 is equal to 8 plus -4 over 2, and then you are getting 2 nanocoulombs also. You can calculate. But end of day, for other calculation, we should convert it. Nanocoulombs, nano, pico, micro, just let's give all units in order, and then we can use for other questions also. Maybe end of period, end of lesson. Okay, let's finish our all questions, and then let's give you all units, end of period, pico, nano, micro, all units in order. We should write it. We are going to write it down and we'll explain. But for now, let's finish our questions. Question 23, done. Question 24. How many electron transfer? One more time, long question. What was our final charge? It was Q final is equal to 2 NC. This is our Q final. You can use this one to calculate number of electrons transferred. This one a bit longer, others easy. So I hope you are getting better. You are getting this topic learning. So with practice, I'm sure you will get it. But please try first. Okay, question 24, your turn. All right. I hope you have done. Okay. Let's continue. You can see in 2 seconds how we are going to just stop video and try first. All right, please do that. So now we are looking for number of electron transfer. First of all, charge is equal to N times QE. N is equal to delta Q over QE. Delta Q is what? Q final minus Q initial over 2. So what we have, N equals Q final is 2 times 10 to the power of negative 9 minus what we have, let's use B, minus 4 times 10 to the power of negative 9 over 1.6 times 10 to the power of negative 19. So when you do this, the negative making positive, and 4 plus 2 is 6. 6 times 10 to the power of negative 9 over 1.6 times 10 to the power of negative 19. So let's take our calculator and let's calculate 6 over 1.6. So what are we getting? 3, N is equal to 3,75 times 10 to the power of 10 electrons. Done. As you see, after long calculation, we calculate how many electrons transferred. 3,75 times 10 to the power of 10 electrons moving from B to A. You know direction already, right? So we can carry on with our next question. So next 125, what type of force between these two? Okay. All right, we should just add our objects. All right, so objects here, P and T now. What type of force between these two? Now you have plus 7 minus negative 3, minus 3. All right, negative 3 and positive 7. Please try first. What kind of force we have? All right, I hope you have done already. It is simple one. What we have, attractive electrostatic force. All right, we have done because unlike charges, they attract each other, like charges repel each other. So let's continue with next question, 26 now. So next question, what they ask, they touch each other and separate from each other. What is the force? What kind of force we have between these two after separation, after touching each other? Not now, just after touching each other, after separating from each other. Just a few seconds to try. Please try first. All right, I hope you have done. So now we have same charges when they touch each other. We can check what we are getting. Plus 7 minus 3, 4 divided by 2, getting 2 nanocoulombs. Nano, micro, big, after this, all questions, but after question 30, I will explain. So we have same charge after touching each other. Our answer is repulsive electrostatic force. Electrostatic force. I hope you get it. So this is our answer for question 26. 27, let's see what they ask. Direction of electron transfer. Yes, one more time, you should remember. That's one important point. Let's see what we have. Please try. 1, 2, 3, 4, 5 seconds. Yes, time is over. I hope you've done already. It's a simple one. Electrons moving from T to P. That's right. T to B, the P, the T to P. Yeah, from less number, from negative number to positive number, because T has more electrons. When they touch, electrons move from T to P. Done. Let's continue with next question. Question 28. Calculate the new charge on the object T. Sorry, we should say T, object P. So let's calculate new charge. Just carry on with new question, because these two questions, same question. Let's say object T. Okay, let's calculate new charge on object T. Okay, so how we are going to calculate, you know already. Please try first. Now too easy for you, right? Practice, practice, practice. And then when you go to exam, it's going to be very easy for you. So, okay, please just try first. Okay, Q final equals Q1 plus Q2 over 2. What we have, Q1 is 7 plus 7, and then plus minus 3, and divide by 2. Q final is equal to plus 7 minus 3, plus minus getting minus, so getting plus 4 over 2, getting 2 nanocoulombs. All right, remember, if you have NC, you must convert it. So final answer with coulombs, 2 times 10 to the power of minus 9, negative 9 coulombs. Done. New charge on each object, P and T. Done. Okay, let's continue with last question. After this question, we are going to write all units in order, pico, nano, you know, those things. All right, so what we have now, they touch each other and separate from each other. How many electrons transfer? They're asking you. We calculate already final charge. Final charge is equal to, what was it? 2 nanocoulombs. You can use this one to calculate number of electrons transfer. Please try first. Like always, you are trying first. Try or cry. So you should try. All right, let's continue with our answer now. Q equals N times QE, and then N is equal to delta Q over QE. So we can write Q final minus Q initial over QE. Okay, let's calculate it now. N equals, Q final is 2 times 10 to the power of negative 9 minus, let's use negative 3 times 10 to the power of negative 9 over 1.6 times 10 to the power of negative 19. Positive, negative, we'll check on top if you get positive. So plus, negative, negative making plus, yeah, 5, positive. 5 times 10 to the power of minus 9 over positive 1.6 times 10 to the power of minus 19. As you see, you are getting on top positive, and then this one is positive. Number of electron transfer, let's calculate 5 over 1.6. And then we are getting our last answer. So 3.31 point, we can make it. What's that? 3.14. So 31.25 times 10 to the power of 10, 11. Okay, we should just recalculate this one. All right, 31.25, 10 to the power of 9 electrons. If something is wrong, you can recalculate and get correct answer. All right, so we have done for today, questions done. And then only one thing left. What we are going to do, pico, nano, all those units, we are going to make our list. And then when you see any unit, just like this NC, and then how you are going to convert it. That one we can answer, we can finalize. So maybe another video we can make it, okay, because it's about electrostatics. Maybe we can make another one. I can share a link with you. You can check that one, nano, pico, coulombs. All right, I think it's much better like that. Everyone can see, not just for physics, not just for electrostatics. You know, oh, that one very important. So we can just make another video about nanocoulombs and picocoulombs, everything. All right, guys, thank you very much. See you next lesson. So today we have done electrostatics questions on nano, pico, those things left, but another video is coming now, and then you can see on the link that video and then you can try. Thank you very much. See you next lesson.